Good morning, my darlings. Okay, so today what we're going to look at is we're going to look on the calculator and we're going to do several things. We're going to use a list and spreadsheet in order to enter some data. Then we will go to the calculator page and we will find a curve of best fit, whether that function is a line, an exponential function, a quadratic, a cubic, a quartic, a logarithmic function, or even a sinusoidal graph. The method is the same no matter what. Then we're going to practice graphing a trig function and adjusting the window for that trig function. We will also use a calculator page to evaluate trig functions when we have angles that are measured in both degrees and radians. And finally, we're going to use a graph page to solve a trig equation. And the method we're going to use is awesome because it works for any equation that you ever have. But using a trig equation allows us to show you a couple of new extra tricks hiding in there and some techniques on your calculator. So here we go, guys. So our first problem is a regression problem. The following data represent the amount of money Tam is saving each month since he graduated from college. Determine the line of best fit. So we are going to go to our calculator. We're going to use a list and spreadsheet to enter the data, and then we'll find the linear regression equation. So we're going to add a list and spreadsheet page. Now the catch is you have to give these columns a name. You can type the whole name month if you'd like, but I know it's very difficult to type on this alphabetical keyboard. So if you just want to use the first letter M for month, and then say S for savings, that is absolutely fine with me. Don't bother trying to capitalize them because the calculator is going to change them to lowercase anyway. Now it's data entry, 1, 2, 3, 4, 5, 6, 7. Now I'm going to enter my savings, 70, 81, 91, 102, 118, 132. Now notice, I want to draw your attention here. Notice how all my other numbers are right justified and this one is left justified. As long as it's left justified, the calculator does not know it's there. You have to get out of that cell and make it right justified in order for this to work. If you don't, you're going to get an error message. So once your lists are entered, they're the same length. Pause the video if you need to. Now we're going to add another page, and this time a calculator page. Menu, statistics, stat calculations, and here is where we can find all of our regression types. There's all kinds: sinusoidal, logarithmic, exponential, power, quartic, cubic, quadratic, median line, which we'll never use. Now notice there are two linear regressions. We usually write our equations in the form mx plus b, so we're going to use 3. There are other people who write it in the form a plus bx. Oftentimes that's in different sciences, but we're going to use the one here. Both of them are correct, so it really doesn't matter. Choose linear regression. Now you have to tell the calculator, where did you have your x values? We had them in M for month. Then if we tab, we want to find our Y values. We had those in S for savings. Now, if I tab, this is very important to pay attention to. Not so much today's problem, but if we ever have to use the equation later on in the problems that I've given you, we need to know where in the calculator this is. So the calculator is telling us that the regression equation is going to be entered into f1 of x. Now, oftentimes what I will do, instead of naming my equation y equals, I will write down f1 of x equals. Okay, then you can tab all the way down, or you can hit enter twice to press OK. Now we have all the information we need in order to write our line of best fit equation. One of the few things I dislike about the TI-Nspire is here where it says regression equation. This is not an equation because there is no y equals, and that's the first thing. Now remember when we looked on our calculator and we saw that the function was putting it in f1 of x? It does not matter to me whether you call this function f1 of x or y equals, but it has to have a name, okay? And then the form is mx plus b, so our m is 12.75 times x plus our b is 41 point, let's say we go to the nearest thousandth, so 2, 8. Now the 7 behind that 5 tells us to make the 5 a 6. And there we go. Either one of those equations is perfect. Next up, we want to sketch the graph of y equals 3 sine of 2x. Then we're going to zoom trig, and then we're going to change the window settings to look like the settings below. Okay, now one thing I will give you a heads up. This negative 6.238, remember that pi is 3.14 something something something? Well, guess what? 2 pi is 6.28 something something something. So this window is going from negative 2 pi to 2 pi. And then we're using a scale of pi over 2. That 1.5708 that you see on the graph paper, that is pi over 2. Okay? Also, before we go, please make sure that your calculator is in radian mode. Our calculators should always be in radian mode. Those of you who are taking physics, you're going to need to watch your calculator mode when you change between math and science class, because science puts you in degrees, we're going to put you in radians. Okay? So physics kids, you especially have to watch out. So we're going to press Control Dock to add a page, and we're going to add a graph page. So our function was y equals 3. Use your trig button to press sine to x. It doesn't matter if you close the parentheses or not. The calculator will take care of that for you. Okay, now we were instructed in directions to menu. We're going to window zoom, and notice there's a setting for zoom trig. So we're going to choose 8 for zoom trig. And what this does is it changes the x min to negative 2 pi and the x max to positive 2 pi. Now we're going to make that even better. So we're going to menu. We're going to window zoom, and we're going to window settings. We're going to leave the negative 2 pi to 2 pi, but we want to count by pi over 2. So we're going to use our pi button over here, pi divided by 2. Did you know you could put division problems in there? You can. Tab, let's just change this to a nice integer, negative 4, tab 4, tab. Let's count by ones on our y-axis, and we'll tab to OK and hit enter. Now we have our graph. So now if we try to copy this graph, at the origin we were at 0, then halfway to pi over 2, we're up at a height of 3, pi over 2 is 0, halfway between to the next point, we're at negative 3, 0, high, 0, low, 0. We can also continue this backwards. We were high 0, then we're going to be low, 0, high, 0, low. So all of our peaks and valleys are halfway between the indicated, between our scale that we had set for the x-axis. We're going to do our best to make this smooth and rounded. Notice when your graph is below the x-axis, it's curved up. When your graph is above the x-axis, it's curved down. That is important. The way the graph curves, there are no straight segments, there are no pointy peaks or valleys. Okay, there we go. I'm going to remind you, our calculator is in radian mode, and we're going to find these values. The second one, the angle is in radians, but in the first one, the angle is measured in degrees. And we will look right now how to do that. Now we're going to Control Dock and add a calculator page. Make sure your calculator here is in radian mode. I should have said that on the last problem, but if it's not, click here, it'll change to degree mode. Click again, it'll change to radian mode. If yours still has a setting wheel, your home calculator has a setting wheel here, and you can't click to change this, bring your calculator in and I can upgrade the operating system for you or help you learn how to do that. So then you'll have all the features that we have, okay? Especially if you're using an older siblings calculator, the operating system may be a little outdated. Okay, so now we're going to use our trig key over here on the left-hand side. We're going to use trig. We want the sine of 73. Now, where the pi button is, we're going to go to pi, and right below it is the degree symbol. So arrow down and hit enter. Now you can press enter, and here is our sine. Then we also want to find the cosine. So trig, arrow over to cosine, and press enter. We're going to use our fraction template, which is control division. We're going to put 5, press the pi key, hit enter to get the pi, arrow down, and then put in the 8 because we had 5 pi over 8, hit enter. Now we have the value of cosine of 5 pi over 8. Okay, so these are the values we had on our calculator. We now want to round to 2 decimal places. So that means we're going to have 0.9, but this 6 tells us to make the 5 a 6. Over here, we're going to have negative 0.3. That 2 is going to tell us to leave it an 8. And there we go. Now, we want to solve the equation for solutions in the interval. That should say 0 degrees, less than equal theta, less than equal 360 degrees, using a graph page. Using the calculator page, we're going to convert our solutions to degrees. Now, remember when I told you at the beginning that the way we solve this equation works for any equation they ever give you, that we can ever give you, anybody can give you. You take one side of the equation and you enter it in f1 of x. You take the other side of the equation and you enter it in f2 of x. Then you look for the intersection points. The x values of those points are the solutions to your equation. So for us, on the graph page in f1 of x, we're going to enter 2 sine, now here's the catch, can't put theta, x, and remember your calculator is going to open parentheses, so we have to close it before we minus 1. f2 of x equals, we're going to put the right-hand side of the equation, which is 0. Let's go put that in our calculator. This time, I'm going to press Dock, Insert, and I'm going to put in a problem so that it's not connected to anything else we've done. I'm going to enter a graph page. Make sure you're still in radian mode. In f1 of x, we said we were going to put 2, go to trig to find the sine. It opens parentheses, x. Don't forget to close the parentheses before you subtract 1. Then we're going to arrow down, and we're going to put the right-hand side of the equation, which is 0, and we press enter. Now, the other thing we need to do is we need to adjust this window. So we're going to go to Menu, Window Zoom, and let's just do Window Settings. Now, they told us the x values were between 0 degrees and 360 degrees, but we're in radians. So that means we're between 0 radians and 2. Go to the pi to get your pi radians. And we can tab, you can leave this on auto if you want, but some people always like to have pi over 2 so that it's familiar to them. That is fine. I think I'm also going to make this -4, tab to 4, tab. You can leave it on auto or change it to 1. That is totally up to you, and hit enter. Now we can see there are only 2 points of intersection. So since I have to find 2, I'm going to go to Menu, Geometry, Points and Lines, and Intersection Points. Click on the sine curve, click on the line. Notice we've got our 2 points. We have to escape out of that. Okay, so I've got my 2 points here. Now remember, here's the catch. We are in radians. So these are radian angles. Now, another thing I want to show you, I want to point at that x value. And if you press Control Menu, which I can't do on the computer, so I am right-clicking, your Control Menu is a right-click. And if you choose Attributes, we can show you there are many more decimal places hiding in here, okay? And the same is going to be true for the other one, but I'll show you that in a different way. What we're going to do, because we have to change these radian angles to degrees, we're going to store the values. Now, there's a reason we do this in radians. There are people who will graph with degrees on an x-axis, but that is not mathematically correct. Okay, this is a real number line where they are linear measurements. Degrees are not measurements of the same type. They are not real numbers that can go on a real number line. Radians, however, are. Remember, they were the actual measurement along the arc length, okay, of the unit circle. So you can put radian angles on the x-axis. You cannot put degrees on the x-axis. Now, we're going to point at the x value. We're going to control menu, and then you're going to choose store. And you can put this, notice it says VAR, that's for variable. You can pick any letter you want. Working on an alphabetical keyboard, I tend to start at A and just keep going, unless I know it's representing C for cost, then I'll use C. So I'm going to hit A and I'm going to press enter. Notice this is now bold, and if I hover over it, it says it's linked to the variable A. I'm going to do the same thing with the other point. I'm going to point at it so it says text, control menu, store, pick a letter that you want to store it in. I'm going to put it in big and I'm going to hit enter. There it is. Now notice it shortened it again, but that's okay. Next thing is we're going to control dock and we're going to add a calculator page. Now if I type A and press enter, look at that. And if I type B and press enter, there are those radian angles with all those decimals that we didn't have on the graph page, but there's even more behind them. The calculator is rounding also. We now need to change these radian angles to degree measures. Now to change a radian angle, we take the angle times, I'm going to use my fraction template, 180 degrees over pi, and hit enter. So 30 degrees is our first angle. Then we're going to do the same thing. Now I'm going to show you a little trick here. I'm going to arrow up twice and hit enter. It copies what we just did, but I'm going to backspace, and then I'm going to delete the A and type B. I just want to make sure you know that little trick about being able to copy things. And if we hit enter, there's our second angle, 150 degrees. So all our work on the calculator led us to find that theta equals 30 degrees or 150 degrees. And you'll notice I have written here the steps that we did on the calculator, so that if you want to take a moment, go ahead and copy down those notes. Otherwise, guys, have a great day.